Hi, this is Mr. Ward, and I'm going to do a shorter, to the point video on how to use sneaky multiplication tricks to solve complicated or annoying multiplication problems without resorting to a calculator or to the traditional algorithms. You'll see I am using a calculator, but that's mainly just to confirm that I am not making this up. You can see transparently what is happening here. So here we have 993 squared. So here I'm going to use a perfect square structure. Here I've got two different numbers, and I'm going to look for a way to turn these into a difference of squares structure. So the perfect square structure is going to be either a plus b or minus b. In this case, I'll probably end up using a minus b. So a minus b squared, which is going to equal a squared minus 2ab plus b squared. Okay, and the reason I'm probably going to use the minus one is I would rather subtract 7 from 1,000 than add 93 to 900. Okay, so what I mean by that structure is I'm going to take 993 squared, and I'm going to come up with some number that is reasonably easy to work with. And 1,000 is close to it. If I subtract 7 from it, I get 993. Now I'm going to be squaring that, and you'll see that I get the exact same thing here. Okay, let's go through the process. I'm going to take the 1,000, that'll be my A, and the 7, that'll be my B, and I'm going to plug it into this whole structure. Okay, so it's going to be, actually, I'll go ahead and just copy this structure right here, and I'll just plug and play. Sometimes it's useful to use those structures to work through the problem. So A squared becomes 1,000 squared because 1,000 is my A. That also becomes 1,000. And now I'm going to change B into 7. So that'll be a 7. And that'll also be a 7. And now I have the exact same answer popping up here, but I can just work this all out. 1,000 squared is 1,000,000. 1 followed by 6 zeros. 1, 2, 3, 4, 5, 6. I'm going to subtract 2 times 1,000 times 7, which will be subtracting 14,000. And then I'm going to add 49. So when I do all that, 1,000,000 minus 14,000 is going to be 996,000. Okay, so 1,000,000 minus 14,000 becomes actually 900. That's actually 1,000,000 minus 4,000, so 986,000. There, I fixed that. Okay, and actually there's a pretty good clue that I was right to fix that. And I'm going to add 49 to that. So adding 49 just means I put 49 in for the last two digits. And there it is, 986,049. This would be a little easier to see if I did it vertically, so I will quickly do that here. So this is going to be 1,000,000, like this. I'm going to be subtracting 14,000 from that. Get my zeros in for 14,000 and a 4 and a 1. So I'm subtracting that. So there's the zeros that I get for that. And that's going to be a 6. And that's going to be 9 minus 1 will be an 8. And that will be a 9. And I borrowed from this and made it nothing. So there we have 986,000. And then since I'm going to also add 49 plus 49 here, I'm just going to erase those last two zeros and replace them with a 49. So I'll put a 49 up here to remind myself that I'm adding that in. Okay, and so that's 49. Okay, cool. Now, if I had instead had 1,007 squared, so I'll just set that up really quickly. I'm not going to go through all the process. I've had 1,007 squared. That would end up being 1,000 plus 7 squared, which would be 1,000 squared. And this time it'll be plus 2ab, so plus 2 times 1,000 times 7, and then plus 7 squared. And we would be able to work that out reasonably easy. A million plus 14,000 plus 49 is 1,014,049, which is what that gave us. Okay, so that one you can even mental math. When it's subtraction, it takes maybe a little bit more doing. Okay, this is going to be a difference of squares, and what I'm looking for is some number that I could subtract and add the same thing to. And so 589 and 611 are both 11 away from 600. So I can just treat this as 600 minus 11, which is 589, and 600 plus 11. Okay, and then I'll end up using the difference of squares structure, which, if you recall, we got if I have a minus b times a plus b, I get a squared minus b squared. And so I'll just put that all together. This is the 6, this is the a minus b, this is the a plus b. So I'm going to just square this, and I'll square this, and I'll subtract them. So that'll be 600 squared minus 11 squared. So that'll be 600 squared is going to be 36 followed by 4 zeros. So 360,000, and that'll be minus 121. So once again, we got subtraction. So I'm going to go ahead and clear this stuff out of the way. And I will set it all up so I don't lose track of where I'm borrowing and so forth. Change that to blue. So I've got 3, 6, 4 zeros. 1, 2, 3, and 4. And I'm going to subtract 121 from that. Okay. So to do this, this has to become, this I have to borrow from the 6, so that's a 5. So this will become a 10, but then it becomes a 9, because then I'm immediately borrowing here, and that's a 10, and it becomes a 9, and this is a 10 and becomes a 9, and that's a 10. Okay, so 10 minus 1 is 9, 9 minus 2 is 7, 9 minus 1 is 8, and then that's a 9, and that's a 5, and that's a 3. So I've got 359,879. Did I get that right? Yes, I did. Check. Okay, we're good. All right, hopefully this shorter video gave you a pretty good feel for it. I made a longer video that's got a whole lot more detail and more problems worked. I encourage you to pause it and see if you can come up with your answers yourself and prove that it works. Hope this helps.